Alright, we want to look at the volume created by this situation here. So we have the region bounded by the curves square root of x, 0, and x minus 2. And we're going to do this by rotating this around the x-axis, and we're going to use the cylindrical shell method for this. So the first thing I'm going to do is I'm going to graph this region in question. So I'll need an axis. This will be my y-axis. This will be my x-axis. And I am going to be rotating about the x-axis here. So I'm going to want to graph these functions and look at points of intersection. So I think I'll start with the line y equals 0. That is the x-axis itself. So I will just trace a little orange region over the x-axis here. And that's that. Now I'm going to look at the y x minus 2. So I need to put some rough hash marks. Let's say that'll be 1. That'll be 1. Which means roughly that's 2. So that's 2. Whoops, that's 2. Okay, 2, 3, 4. Probably should save myself a graph version to draw on when I need to, but that's fine. So when this is 2, that's at 0. When this is 4, it's at 2. So the line x minus 2 we really only care about the first quadrant, but just so we get a picture, this is the line. And so I've graphed these two things. I have this bottom curve here, and now I need the y equals the square root of x. And some key points on this: it passes through 1, and it passes through here. So I've got this curve here, and let's use a light blue. Right, this region in here. Let's see if the paint tool works on this program. Let's see if I use my paint bucket. There we go. Kind of, sort of. That's the region that we're going to rotate to make the volume. Don't know why I have little black bits there, but I do. Alright, we won't obsessively focus on those. So I want to use the cylindrical shell method, and the cylindrical shell method needs me to have my shells going around where I rotate, which means I'm going to be integrating in y. So that means I'm going to need to rewrite these functions in terms of y being the independent variable. So I'm going to rewrite each of these functions. I'll do it over here. X equals y squared for the first function. This is a boundary that we don't need to rewrite. And the second one is x equals y plus 2. Now my volume from the cylindrical shell method says that I'm going to have the integral from a to b of 2 pi, the shell radius, times the shell height dy in this case. And so the shell radius, each shell is going to be an element rotated across here. And so as I rotate the elements across, their radius will vary in y. So the shell radius is going to be y. I'm going to pull my 2 pi out front. Let me rearrange this. We'll put 2 pi out front. We'll put my integral here. The shell radius is y, because as I move across in y, my radius of my shells will expand outwards. And so now I need to figure out the shell height. And the height will be, as I move across in y, it'll be this element here minus here. So that will be my rotating shell. That's some radius away. So I rotate each of these shell elements. My height is this function minus this function. So it's y plus 2 minus y squared dy. And now I need to find where I'm going to integrate through in y. Well, I'm starting here at 0. And I'm going up here to where these two curves meet, which is at 2. So this will be from 0 to 2. So leaving the 2 pi out here, I'm going to move the y through this polynomial, but I'm going to do it in polynomial order. So it's going to be minus y cubed plus y squared plus 2y dy. This isn't bad to integrate. I'll move up to here. Still going to have my 2 pi outside, and that's going to be y to the 4th over 4 with a negative sign in front of it, right? Plus y cubed over 3 plus y squared, all evaluated from 0 to 2, right? Because this goes up to 4 divided by 4, up to 3 divided by 3, up to 2 divided by 2, so the 2's cancel. And let me brighten up my color here so it's visible as we will do our substitutions in. Nice thing is the 0 doesn't do anything, so we only have to worry about this being 2 pi minus 16 divided by 4, because 2 to the 4th is 16, plus 8 divided by 3, plus 4. Well, this is a negative 4 and a positive 4, so these cancel. And this becomes 16 over 3 pi as the volume for this region rotated around the x-axis.